Before I start chapter 7.2, let me do a quick review on finding the volume of a cylinder. Okay, you know what the cylinder means? So the cylinder is made of like circles, right? You can think of like that. So because cylinder, there are different type of cylinder, but I'm considering the right circular cylinder. It has a circular base. Okay, this is called cylinder, right? So what is the cross section of the cylinder? On the top there is a circle, on the bottom there is a circle. Let's say that the radius of the circle is r. Okay, so how do I find out the volume of the volume of the cylinder? First of all, we need to find out the volume of the base. So base area times height is the volume of the cylinder, right? So what is the base area? Base area is the circle. Area of the circle is pi r square. Pi r square times the height. Let's say this is h. Okay, pi r square h is the volume of the cylinder. Okay, so volume of the cylinder is pi r square h. Now you want to find out little different thing here. Suppose that there are two cylinder and then one cylinder is you are putting one cylinder inside another cylinder. Okay, suppose there is a bigger cylinder there. Okay, like there is a bigger cylinder there. All right, so let's say that this is a bigger cylinder. All right, and then suppose this has a, let's say this has a height h. Okay, and then this has a radius. Let's say radius is big R. Okay, big R, that is a bigger cylinder. Now I am putting a smaller cylinder inside the bigger cylinder. Okay, that is the center. So I'm putting inside that, I'm putting a smaller cylinder there. Okay, that's what it looks like, right? If I do that, oops, my drawing is not very good, but that's what it looks like. Okay, now suppose that the smaller cylinder has a radius a little r. Okay, little r there, little r. Now the thing is, suppose that both of the cylinder are empty inside. Okay, so the volume of the bigger cylinder is pi r square h. Both of the cylinder have the same height, right? And the volume of the smaller cylinder is pi and then lowercase r square h, right? That is the volume of the smaller cylinder. Now how about the volume of the region between those two cylinders? So what is that volume of the region between those two cylinders? Is basically that region I'm talking about, that region, right? Volume of that region between those two cylinders. You see that? That region I'm talking about. Okay, so if you are finding the volume of the region between those two cylinders, okay, then that's how you find out. How do you do that? You find out the volume of the bigger cylinder, the whole cylinder, outside cylinder, right? And then you subtract the volume of the inside cylinder. Okay, you subtract the volume of the inside cylinder. That will give you the volume of the that shaded region, blue shaded region, is volume of the whole cylinder minus volume of the inside cylinder. Okay guys, okay, suppose that you have a ball. Okay, suppose that not really a ball. Let's say that, suppose that you have a big cylinder. Let's say that you have a big cylinder there. Okay, okay, so that's your big cylinder. But instead of putting another cylinder inside, I'm putting like a cup. How that look like? I'm putting inside the big cylinder, I'm putting a cup. Okay, so that will look like, let's say that will look like this. Okay, let's say that this cup is like this, like that, right? Okay, so how do you find out, and suppose you are interested to find out the volume of the region that is outside this cup or the cone, I would say, right? It is cone inside, so outside the cone, but inside the bigger cylinder. What I'm talking about here is on the bottom it will be the whole thing, right? On the bottom it will be the whole thing, and on the top you are basically finding that outside the cone, okay, so outside this cone, right, and inside the bigger cylinder. Suppose you are trying to find out the volume of that part. So how do you do that again? So in that case again you will be finding out pi r square h minus volume of cone. That's what you will be doing, right? You see that? That's what you will be doing. So to make it easy, what you can do for this problem is basically you can basically put this solid inside x-axis and y-axis. Okay, let us look at that. So this is x-axis, this is y-axis. I am rotating this a little bit and then I am putting like this. Okay, this is the cylinder, right? This is that cylinder. Okay, you see that? And then my the cone look like this. My cone look like this, right? You see that? My cone look like this. Now my interest here is trying to find out the volume of that's the total cylinder. Okay, the total cylinder, and then minus volume of the total cylinder minus the volume of that empty cone. That will give you the volume between that cone and the cylinder. Okay, so how much is that? Suppose we say that is like this length is h, right? That length is h. This is 0, this is h, right? So that will be, this will be pi r. How much is r here? R is that r, right? That r is the radius. So the r here, let me use different color there. I think the blue color will give me the distinction there. That is r. That is big R, right? That is h. So that is big R. So pi r square h, pi r square h, V equals, that is for the whole cylinder, minus, how can I find out the volume of this? So the volume of this is also, you can think that cone as a cylinder, but the radius is changing, right? That radius is changing. So suppose that this curve has equation, let's say, suppose that this curve has equation y equals to f of x. Because you see that for each x, y is changing, right? The height is changing. That's why y is changing. So what I'm doing here is I'm doing pi and then y square h, because that length is still that length is basically still hold on, that we cannot just think that's fine, pi y square h, but y is changing here. Okay, y is changing. All right, so here what you can do here is, that's how you find out the volume of that part. Okay, volume of that shaded part. So volume of the solid, I would say, if that shaded part is a solid made of some metal, okay, you are basically, this is basically kind of a cup that has bigger thickness on the bottom and smaller thickness on the top, right? And this is also the cup in the on the horizontal position, right? Cup in the horizontal position. So if you assume that the shaded region is the metal part, okay, that is basically the volume of that metal part is like pi r square h, that is the volume of the whole cylinder, minus pi r square, pi y square h, y, where y is changing. Here y is 0, the radius is 0, but here the radius is changing, increasing like that, right? That's why I'm writing y. Here the r is constant. Here y is a variable. It is changing for each x. Okay, so that's how you find out the volume of the solid here, or volume of the solid, or volume between two cylinders. Hi, in chapter 7.1 you learned about how do we find the area between two curves, right? So we saw mainly two cases, two scenarios. The first scenario was if the two curves are not intersecting inside an interval, and the another scenario was if they intersect inside an interval. But in either case, the area between two curves is basically the definite integral from a to b. A is the left bound of the region and the b is the right bound of the region. And then so the integral of through a to b and the upper function minus lower function, right? That's what we did, okay, to find out the area between two curves. So here on this section, what we are going to learn is we are trying to find out volume, okay? So we want to find out, so suppose, let's say this function here, so y equals to f of x is a function, okay? So this is the region, okay, under that curve above x-axis and between x equals to a and x equals to b. So instead of finding the area, what we are trying to do here is we want to revolve, okay? We want to revolve this region about x-axis. How that look like? If you revolve it, then it will look like it will look like this, right? So it will look like, so the image of that will look like that, right? And you are revolving, meaning that you will get a solid, okay? You are rotating basically that shaded region, shaded by the red color. We are basically rotating, this region, the original region, this region, right? But we are rotating that about this line, okay, about x-axis. So how do now we want to find, so we will see a region here, right? We will see a solid here. We will get a solid that is between a and b, and then this solid is made of many circles. You see that? Does it make sense? So what we are doing here is we are rotating, or we call revolving, okay? We are revolving this region, this set region around this line, and you will basically get a solid. This solid is made of so many circles, or we call disk, okay? See this? So this is the leftmost disk, right? And you draw another disk here, you get another disk, and there are so many. If you stack the disk on the right side across the horizontal line, that the collection of all these stacked disk, right, will form this solid of revolution, okay? So it is basically the stack of all these disk. You understand that? Now, how do I find out the volume? So the volume is basically the area of this disk plus area of the second disk plus area of the third disk plus area of the fourth disk plus area of the fifth disk, and so on. But that disk must be very, very thin, okay? Let's say that the disk has each disk has thickness delta x, okay? This disk has thickness delta x. So what is the area of the first disk? It is like, basically it is a circle. If the thickness of the disk is very, very thin, it is kind of a circle, right? So what is the area of that circle? It will be pi, and then what is the radius? Let's say this radius is, that is the radius, right? So radius is basically the y. You see that for each of the disk, the radius is that. For this disk, for the tallest disk, that is the radius, right? For this disk, that is the radius. For another disk, that is the radius. For another disk, that is the radius, and so on. For the smallest disk, that is the radius. You see that? That is the radius of the smallest disk. Basically, y coordinate is the radius of each of the disk. But that y coordinate is changing though, right? So y is not constant. For this disk, y is very small. For the another disk, y is bigger. For the last disk, y is the biggest. So the radius is the biggest, okay? So basically pi and then y square will be the area of each of this disk. Now we need to, and then times the length of the disk is delta x. I mean the the thickness of the disk is delta x. Now if you add summation, if you write the summation of pi y squared times delta x, that will give you the total volume. Okay, but when the delta x is very small, when the delta x tends to 0, this summation will tend to integral, okay, between a and b. So basically, if you get the disk at a, if you get the disk little right of a, another disk little right of that disk, and then so on, so the summation of the area of all these disks will form basically the volume of that solid, formed by revolving the upper region, okay, this upper region, this region, right, revolving that region around the x-axis. That's why we see that volume of a solid obtained by revolving the region under y equals to f of x above x-axis inside the interval AB, and if you revolve that about x-axis, then the volume will be the integral of that, but the pi is a constant. So what you write is pi integral from a to b y squared dx. That's what you will get, because when delta x tends to 0, we write that dx, right? So basically you can write this as a pi, and then a to b, you can write y is basically fx, right? F of x, and then bracket, let's write on bracket square, and then dx. So if you are rotating about x-axis, that's what you get. Okay, now on this second figure, I want to rotate about y-axis. I want to rotate this region, I want to revolve this region about the y-axis. How that look like? If you revolve that, then that part will be here and this part will be here. So if you rotate it, you will see like that, right? You'll see like that, and then this is the bottom part, and then that will be the top part, right? So it'll look like a ball. You see that? So this is the final solid you will get if you revolve this shaded region about y-axis. You see that? That's what you will get. So what will be the total volume here again? So you will find out the area of this circle or the disk, and then take another disk, find the area of that disk, find another disk, find the area, find another disk, get another disk, find the area, and you add all the areas there. Okay, so you add all the areas to get the volume. So what is the volume of this disk? What is this radius? So radius of this, the very bottom disk, will be basically the x coordinate of this point, right? That will be like, this point is x comma y, right? So x coordinate is the radius of the disk. For each of the disk, x coordinate will be the radius. You see that? X coordinate will be the radius. So the area of the bottom disk will be pi and then x squared times delta y. We are taking the thickness of each of the disk is delta y in case of the, if you are revolving about y-axis, right? So you'll get pi times x squared times delta y. That is for the very bottom disk. If you take another disk and like that, see this x is changing, right? For each of the disk, the radius is changing, radius is increasing. So x is changing there. So if you add all those, okay, if you add all these area of the disk, right, then you will get the total volume of this solid. Okay, now if you take this disk very thin, that is if delta y tends to 0, like we did delta x tends to 0 there, then the sum become the integral, right? So how that look like then? So if when the axis of revolution, that we call the, here axis of revolution is y-axis, here axis of revolution is x-axis. If the axis of revolution is a vertical or y-axis in this case, so that the volume will be pi and then integral c to d. This is c, that is d, right? C to d, and then you write x squared dy. Okay, that is same as pi integral c to d, and then x squared is f of y squared, because you see that, sorry, g of y, right? G of y squared, because x is g of y, and then dy when delta y tends to 0. So these are the formula, okay? Okay, so another thing is here we are revolving about x-axis and y-axis. So instead of revolving about x-axis and y-axis, you can revolve about certain line, because you see that, let's see that, suppose this is x-axis, this is y-axis, right? Suppose that you want to revolve about, let's say, x equals to 2. If you have a curve like this, and suppose this is like A, this is like B, okay, this is B. Now suppose you want to revolve this curve y equals to f of x, this region. If you want to revolve the region under y equals to f of x, let's say, about x equals to 2, how that look like? This will look like that, right? And then you will be getting this solid. You see that? You will be getting this solid. Okay, now to find out the volume of this solid, again you will be using the disk method again. Okay, pick a disk, find the radius, and then find the area of that circle, kind of. Okay, so area of the disk and area of the circle will be the same. Okay, find another, get another disk, find the area of that disk. But what will be the radius in that case? So it is not just y, because y will be the whole thing from A, but that radius is above 2, and then below that y, and then minus 2 will be the radius, right? So the radius basically will be y minus 2, that is fx minus 2. So in that case, the area of the disk will be, sorry, the radius of the disk will be y minus 2. So the area will be, pi and then r squared, right? So and then times delta x. If you want to find out the thickness of the disk, so the volume of that disk, so basically the volume of that disk will be pi r squared times delta x, right? So what will be the volume of the total solid? That will be the summation of the volume of the tiny disk, or summation of the area of the all these circles, right? That will be pi and then integral a to b. What is the radius? Radius is y minus 2. Y minus 2 square and then dx, right? You can think like that. That will be the total volume. Okay, or you can say the sum of the volume of the disk, or sum of the area of the disk, I could say, because whenever the disk, the thickness of the disk is very, very small, at that time it is just kind of circle. Okay, just finding the area of the circle. So the volume will be pi r squared times delta x, volume of the disk, and the summation of all the volume of the disk will be pi r will be y minus 2 squared and then dx. So how do you find out the volume of a cylinder? Volume of a cylinder is basically, so this is the radius of the circle, right? So the summation of the area of all the circles, right? So this is like h. So it is like pi r square is the area of the circle times the thickness of that. This thickness is h. So pi r square h. That's what we are doing to find out the volume of a single disk, right? And if you add all the volume of all the disk, that will be the integral of pi and then r is y minus 2 squared dx. That will give you pi and then integral a to b. Y is f of x minus 2 and then square and then dx. If you are revolving about y equals to, I'm sorry, this is y equals to 2. Y equals 2, so that is y minus 2 squared, not x equals 2. Y equals to 2. Okay, guys. All right. So so that's how you do it, and then we will do some examples. Then things will get clear. Okay, guys. All right. Let us do example number. So it is not exactly example number 5. I am doing something similar to example 5 from the book. Okay. All right. Let us see. Find the volume of solid formed by revolving the region under y equals to root x about x-axis in 1 through 4. So it is y equals to root x, right? So y equals to root x look like this, right? It will look like this. That will be y equals to root x look like. But you need this graph only between 1 and 4. This is 1, this is 4, let's say. So this is 1 and this is 4. So you need that graph between 1 and 4 only. So you don't need the whole, you don't need to join that from 0. So that is the graph, right? Now you want to revolve this area under that, you want to revolve this region, okay, about x-axis. This is x-axis, right? You want to revolve this. How that look like? That will look like a solid. You see that? And then like this, and then that solid will look like that, right? The solid will kind of a cylinder, but not exactly, because cylinder has a constant radius everywhere, okay? But it is like a kind of a solid that is similar to cylinder, but not exactly similar, okay? So we are trying to find out between 1 and 4, and we are revolving around x-axis. When you revolve around x-axis, that is the formula that we will use to find out the volume, right? So how do you do that? Volume, let me use a little bright color. So the volume is equals to pi a to b. A is 1 and b is 1 through 4. And then f of x, this is y equals to f of x, square of that, right? Because you see that? That is square of that. So you write root under x square and then dx. That is the volume of the solid. So let us do that. So pi, what is that? This is 1 through 4x dx, right? You see that? So how much would that be? Pi, what is the integral of x? This is x squared over 2, and then the limit are 1 through 4, right? So how much you get? Pi, and then 4 squared over 2 minus 1 squared over 2, right? So how much is that? That will give you, so that is pi 16 over 2 minus 1 over 2, that is 15 over 2. So the final answer is 15 pi over 2. It is the volume of this solid. Okay, again the idea is this. So you are cutting that solid into so many discs, right? And find the volume of each disc, and then adding the volume of each of those all discs will give you the total volume. But so instead of doing that like one by one, what we can do is we can, if the discs are very very thin, well, when delta x tends to 0, the summation will be the integral, right? Like a Riemann sum. You saw that in calculus 1. And then basically finding the volume of each disk and adding is equal to finding the integral of the area of that disk, right? So what we are doing here is finding the integral of the area. Pi r square, radius is basically that quantity is the radius, or that quantity is the radius, or that quantity is the radius. So basically for each of those, the radius is y value. Y is equals to f of x, or in this case it is root x. So pi r square dx, that's what we're doing. So root x square here is basically x, and you just find the definite integral. Okay, so this was the example where the region under the curve is revolve about x-axis. So let us take another example. This example is similar to example number 9 from your book. Okay, so example number 9, so it is given as y equals to x square. So it says find the volume of solid formed by revolving the region left of y equals to x square. So how that y equals to x square look like? Let me draw the picture first. So the y equals to x square will look like, so let me see, x-axis, y-axis, right? So y equals to x square look like this. You see that? So let me make it a little better here. So let me make it y equals to x square a little smaller. This is y equals to x square, right? But the question says between x equals to 0 through y equals to 0 through y equals to 4, because we are revolving. Look at this. By revolving the region left of y equals to x square, that is left of that. And then so if you revolve the whole region, or if you revolve just the right side of the region, you will get the same thing, right? If you revolve it, you will get kind of cup kind of shape, right? So it says this is, let's say this is y equals to 4, y equals to 0, right? You are revolving that region. Okay, so how that look like? This will look like if you revolve it, then it will look like this region, and then you are revolving that. This is a solid that you get, right? This is not exact, but this is what you get. Now what will we, so to find out the total volume, again you will pick a disk and find the radius of that disk and find the volume of that disk. Pick another disk and then do that. So you keep doing that and then adding all those, which is same as saying that pi and then gy square. Okay, pi gy square, because we are revolving around y-axis. You see that? Since we are revolving around y-axis, so the volume is equals to pi and then c to d. This is like c is 0, d is 4, 0 to 4, and then g of y square dy. What is g of y? That is just same as x, because this is like x equals to g of y. So how do I find out that? You need to solve for x. If you are revolving about y-axis, you need to solve for x. So you get x equals to root under y. Since that original function I'm taking on the right side, I'm taking root under y positive side, because you will get plus minus root y. I'm just taking positive side. You can take negative side, no problem, because you will get the same solid if you revolve this part or that part. Okay guys, so this is basically gy, the function of y, that is g is function of y. Okay, you can use this x square. So x square is equals to y, or x equals to root y and square it. So what do you get? Pi 0 to 4 and then x, root y square. So what is the root y square? So root y square is y and then dy, right? Because gy is root y, so square of gy is just y and then dy. So how much you got there? Pi y square over 2, 0 through 4. Okay, so what do you get there? So basically you get pi over 2 and then you write just 4 square minus 0 square, right? So basically what you get is 16 over 2 pi, that is 8 pi. That's what you get. Okay, so here I am rotating around y-axis, rotating that shaded region around y-axis. In that case, the formula is pi r square, again the area of the circle, but r is like x coordinate. So for each of the point, x coordinate is the radius. For this, x coordinate is the radius. For this disk, x coordinate is radius. Okay, on this method basically we are finding the volume. We are just creating disks, many disks, and then adding the volume of the disk. Okay, that's why it is called the disk method. All right, so we will do so many other examples here. The next example I want to do is example number 14. Okay, let us do example number 14. It says that find the volume of solids generated by revolving the region bounded by the graphs of equation y equals to 2x square, y equals to 2x square, and then y equals to 0, and then y equals to, it says x equals to 2. Okay, not y equals to, x equals to 2, and number a, it says about number a about y-axis. It says about y-axis. Okay, number a is about, you want to revolve the solid about y-axis. Okay, and number b is about x-axis, and number c is about the line y equals to 8, and number d is about the line y equals to, you know what, since about x-axis and about y-axis are the same thing as we did on example number 5 and example number 9. Okay, for y-axis and x-axis it's exactly the same. What I'm going to do is I'm going to do c and d. Okay, c is saying about y equals to 8. Okay, so c is saying you want to rotate about y equals to 8. Okay, I want to do that. And for d, it will be about the line x equals to 2. Okay guys, so first of all what I want to do is I want to draw the picture for this. Okay guys, how would the picture look like? So let us first draw the graph of this region given by the question. Okay, So and then we will draw the line y equals to 8, which is the horizontal line. So this is x equals to 1, this is x equals to 2, okay. This is x equals to 2, and this is y equals to 2x squared, okay. And then you are trying to revolve this region, and this is y equals to 0. That line is y equals 0. So it is not actually triangle. Let me draw slightly non-triangle way. So the graph will look like this, okay. So this is y equals to 2x squared. This is x equals to, this is y equals 0, and you are revolving this region about the line y equals to 2. Let us say that this line is y equals to 2. So you are revolving this line, okay. So how that picture look like? If you revolve this region, this solid region about this line, then it will look like this, right? So it will basically look like that, and then you will basically, so when you revolve this around that line, then you will get the leftmost disc will look like that, right? And then the rightmost will look like, you see that, okay. So what will be the volume? Because, and then when you do this, it will look like that as well, right? And then you see that the solid part is this, and this part will be just empty part, right? Because when you are revolving that, you will get like a ball, like kind of cylinder, but it has like different thickness. When you go towards the bottom of the cylinder, then you will get a bigger thickness. It's like the empty part is like a ball, okay. So this is what you will see, okay, if you revolve this. Now, how do I find out the volume of this shaded part? Because this shaded part is everywhere, okay, all around. So how do I find out the volume? It is like volume of the total cylinder minus volume of this empty cylinder or empty ball, right? That's what you find out here. So how do you find out? Let us find out that. So the volume is equals to, you find out the volume of the big total cylinder, volume of the total cylinder minus, you find out volume of empty ball part, right? So empty ball section or the part, you see that. So for the total cylinder, if you want to find out the volume of the total cylinder, what will be the radius? The radius of the cylinder is just 8, right? Because you see that is also the radius of the cylinder. If you are finding, when you are finding the volume of the total thing, the total cylinder thing, then if you look at this like vertically, this is what is happening, okay. You have that cylinder, okay, you have that cylinder, you see that, and you are trying to find out, because that cylinder has empty in the middle, and this is like solid part, this is like that solid part, okay. If you look at like in the vertical manner, this is what you are doing. So to find out the volume of this the shaded part, okay, this shaded part is all around though, not on the side, left side and right side, it is all around, because you are getting that by revolving this region, okay. Now to find out that, you are trying to find out the volume of the whole cylinder. What is the volume of the cylinder? It is pi r square is the area of the bottom times the h is the height. So pi r square h. So what is the height here? Is that height. That is the height. So here, what is that? That is like 0. This is 2. That is given by the question, right? Because x equals to 2 is the rightmost and x equals to 0 is the leftmost, right? So the area of the cylinder here is pi r square h, okay, but r is basically the 8 here. The radius is 8. Radius of that cylinder is 8. Minus volume of the empty part. What is the volume of the empty part? You see that? To find out volume of this empty part or the volume of this empty part, right? To find out the volume of this empty part, what is that? That value is changing. The radius is changing here. Like the radius is changing here. At this point, the radius is 8. But at this point, radius is different, right? At this point, or if you think the bottom part, then you can think like this. At this point, radius is 8. At this point, radius is little shorter. This point, radius is little shorter, little shorter, little shorter, and so on. Okay, the radius is changing for this that empty part. Okay, but how much would that be? That will be the total is 8 minus that y coordinate. 8 minus y coordinate is that radius, right? And then the 8 minus that y coordinate. Okay, that's what you will get. Okay, so how do you write that then? So the total volume is basically, let me erase that figure here. Okay, let me erase that. So what do you get is basically this will be integral. So pi is outside, right? Pi integral of pi r square, right? Integral of pi r square. So 0 to 2, 0 to 2 pi. The volume of the total cylinder is 8 square pi r square minus, okay, the volume of this, the empty part, empty bowl will be, so pi r square, again pi r square for that, but I took pi for both of those, for outer cylinder and then inner ball is pi r square, but for the since I took the pi outside, so pi r square for the big cylinder, the total cylinder, minus pi r is 8 minus y square. That is for the interior ball. Okay, radius of the interior ball. But y is changing, okay? Y is changing, and then dx. Now I'm going to, why do I do dx? Because the axis of revolution is horizontal, like x-axis, like that. Okay, that's why, like x-axis here. That's why. Okay, guys. Now what is y? So that will be like pi 0 to 2. That will be 64 minus. So what is that y means? Y is 2x square. So it will be like 8 minus 2x square whole square and then dx. Okay. Now this will be pi and then 0 to 2. Okay. That is 64 minus, let me use bracket, still use bracket. Now what is that square? It is like if you do FOIL 8 minus 2x square times 8 minus 2x square, that will be 64 minus 32x square plus x, so that will be 4x to the 4, 4x4, and then bracket dx. So if you simplify that, what do you get? You will get pi, there is 0 to 2, and this is just the remaining thing is just the definite integral you saw in calc 2, okay, calc 1. Okay, so 64 minus 64 is 0, and then negative minus negatively positive 32x square, and then minus 4x to the 4, and then dx. Okay, now you can use calculator to find out this definite integral, or just find out that 32. So 32x to the cubed over 3 minus 4x to the 5 over 5. That's the integral, right? And then plug in 0 through 2. So what we are going to do next is we plug in x equals to 2 on both, and then do x equals to 0. Okay, so you will do pi, you will do 32 times 2 to the third is 8 over 3 minus 4 times 2 to the fifth is how much? That is 32 over 5. Okay, that, and then minus, you plug in 0, you will get 0. So you don't need you don't need to show that plugging in 0 there. So now if you use calculator for that, you will get 896 pi over 15. That's what you will get. Okay, that will be the final answer. Again, this is the question number C of part C of question number 14. So next I am going to do part D, that is you are revolving that around the line x equals to 2. Okay guys, let us do that next. So the next thing we want to do is part D. So you are revolving this region about a line x equals 2. So this is line x equals to 2, right? This vertical line is line x equals 2. So if you revolve this region around that, you are revolving like that, right? So what do you get? You will get a solid like this, and you will basically getting a solid like that, right? That's what you will get. Okay, so this is what you will get. All right, and you are revolving around that line y equals to 2. You see that? That's the line that you are revolving about. Okay, so now we need to find out, because since we are revolving around the vertical axis, so your volume formula, volume equals to, you will have pi and then something there, right? And then you write dy. We need the limit of y. Okay, so whenever you plot, so what is that curve? That is y equals 2x squared. When you plug in x equals to 2, what do you get? When you plug in x equals 2, you will get y equals to 8, right? You will get y equals to 8. That length is 8 there. You see that? Because we need the limit for y. Because we have dy, we need the limit of y, 0 to 8. Okay, so we need the radius stuff here. But what will be that? You see that? That is 8. Okay. Now what will be the radius here? Radius of that solid. Okay, what will be the radius of that solid? That basically that will be the, whenever you revolve, that radius of that solid is this part, right? This part is the radius of that solid. So how much is that? That will be basically, the total is 2, right? The total is 2, and then minus that x. So 2 minus the x coordinate, because that this point is like x comma y, right? This is like, the total is 2 and then minus that part. Okay, 2 minus x square, that is the radius. That part is, the total is 2 minus this part. So 2 minus x square, right? So it will be 2 minus x square, but we need a function of y, so x should be changed into y. So how do you do that? So y equals to 2x square. So x square equals to y over 2. So x is equals to under the root y half. That's what x is, right? So I will plug in that thing here. So what do you get? So the volume is basically pi 0 to 8, 2 minus root under y over 2, and then square of that dy. Okay, so I think one thing, important thing here is, if you are revolving about horizontal axis or x-axis, you will have dx. If you are revolving about vertical axis or y-axis or vertical line, any vertical line or y-axis, then it will be dy. Okay, don't forget that. So 2 minus under the root y over 2 squared. So it is just like FOIL, 2 minus root y over 2 and then 2 minus root y over 2. That will be pi and then 0 to 8. It will be, how much would that be? Let me show you that. So that will be 2 minus root y over 2, right? And then 2 minus root y over 2. That's what you have. So how much would that be? 2 times 2 is 4, minus 2 times y over root 2 is 2 root under y over 2, minus y over 2 is 2 root under y over 2, and then minus minus plus y half only, because root y over 2, root y over 2 will be y half, right? So how much would that be? That will be basically, that will be 4 minus 4 root y over 2 and then plus y over 2 and then dy. You see that? So how much would that be? That will be, let me write down here, pi, and then now let's integrate it. 4y, right? The integral of 4 is 4y, minus 4 over root 2. What is the integral of y, root y? Integral root y is basically, so let me show you here. Root y is y to the 1/2, right? So the integral of y to the 1/2 will be y to the 3/2 over 3/2. Basically, that is 2/3 y to the 3/2. That's what you get, right? That will be 2/3 y to the 3/2. Okay, I pulled that root 2 outside here already. Root 2, and then plus 1 over 2 times y squared over 2, and the limit is 0 to 8. Okay, so what we are going to do next is pi. Now plug in that 8. 4 times 8. 4 times 8 minus 8 over 3 root 2, and then 8 to the 3 half. I'm just replacing y by 8 first, right? Plus 1/4 8 square, right? And then minus, you put the 0 in all y, that will give you all 0, because there is y 0, y 0, y 0. That's what it will make. So what do you get? Pi, and then this is 32 minus, how much would that be? That will be 8 to the 3 half, right? So 8 over 3 root 2. So basically 8, you can write 8 as like 2 to the cube, and then by the way, not 2 to the cube, because we want to cancel that 2, right? So you can write 2 root 2 to the square times 3 half. That's what it is, because 2 root 2 square is how much? 2 root 2 square is 4, and then 2, 8, right? That's why we can write, and then you cancel that and that. What you get is 2 root 2 to the third. You see that? 2 root 2 to the 3. Okay, and then plus 1 over 4 times 64. You see that? So how much do you get? That is same as pi. How much is that? 16, right? So 32 plus 16 is how much? 48. So you get 48 minus 8 over 3 root 2 times, what do you get? How much is that? 2 root 2 to the cubed is 2 root 2 to the square. 2 root 2 square times 2 root 2, right? Because 2 root 2 square is 2 root 2 to the cube is 2 root 2 square times 2 root 2, but this is 8. That thing is 8, right? So what do you get there then? So what is the final thing then? So this is basically 8. That is 2 root 2. That root 2 and root 2 cancel out. So there is 3. So it is like 8 times 8 is 64 times 2 is how much? 64 times 2 is 128, right? That will be basically pi, and then 48 minus 128 divided by 3. Okay, if you use calculator or just do the simplification, you will get 16 pi over 3. That's what you get. Okay guys, so that is the final answer. So whenever you are revolving about a line different from x-axis or y-axis, the things, I mean, even if you rotate about x-axis or y-axis, sometimes finding the radius, the actual radius, can be tricky. Okay, so usually what we do is to find out the volume of the solid. If there is like a empty space inside the solid, if the solid have all the solid space, like for example, if you are rotating, let's say if you are rotating this around that axis, then it will be like just a solid, right? Just a solid like this, just a solid like that, right? So it is just easy to find out the radius here, right? But instead of having that, if you are rotating a region, let's say for example, let's say you are rotating a region like this, you are rotating a region like this. If you are rotating a region like this, okay, about y-axis or about x-axis, then the things will be a little bit different. Okay, suppose you are rotating about y-axis, then it will be like, oh, then it will be like this, right? Like this, right? And then you will be, that will be the solid. You see that? In that case, finding the radius of that region will be, you will find out the radius of the total region and then minus radius of that empty region. Okay, so you will basically doing pi r square for the big disk, and then pi r square for the small disk, and then you will be subtracting the volume of the total volume minus the interior volume of the empty region. That's what you should do. Okay, that's what we did on example number 14. Okay guys, so the next thing I am to do is some more examples, okay, that you will see in the next video. All right, thank you.